Solve quadratic trinomials by factoring using the box method, a harder problem. Recently, one of my valued viewers, Viva La Maria, made a comment to one of my videos, Solving Quadratic Equations by Factoring Part 1. He gave the details of a more advanced problem than any of the examples in my video he had just seen. I could have directed him to my follow-up video, Solving Quadratic Equations by Factoring Part 2, which shows the working of examples of greater difficulty than Part 1. Still, the problem he gave me was even a degree of difficulty higher than the problems in this Part 2. This is the problem he gave me. Solve the quadratic equation 18x squared plus 9x minus 35 equals 0. I worked out the problem. I was able to work this one out pretty quickly using the box method and gave him a short explanation of how I worked it out. However, I stopped short of giving the answer. And this was his response to me. In short, he doesn't really want the answer to this problem nearly as much as he wants to develop the skill level to be able to do problems of this degree of difficulty. I really do care about all my viewers and subscribers and try to help them as much as possible, but especially in this case where the problem in question is a natural extension to material I have already addressed, like I had done in Parts 1 and Part 2 videos. Plus, some of my best and most satisfying videos have come in response to questions such as Viva La Maria's. The thing that complicates this problem compared to the problems on my Part 1 video is that we need to find the correct combination of the factors of 18 and negative 35. And that raises our number of possible combinations considerably. Teachers have shown me different methods of factoring these more complex trinomials. There is a diamond method. One colleague showed me a method called bottoms up. At the time, these methods looked pretty good. However, I've easily forgotten these other methods and I just go back to using the box method. So here we go. Here's the box we'll use to factor this quadratic trinomial. We start by placing the x squared term, 18x squared, in the upper left cell of the box. And next we place our number term, minus 35, in the lower right cell of the box. Here's where the complexity starts picking up from my Part 1 video. Both 18, the coefficient of x squared, and negative 35 have multiple possibilities for factors. Numbers like 24, 36, and 48 have even more possible combinations. But starting with 18, the possibilities of factors are 1 and 18, 2 and 9, and also 3 and 6. And then we have the factors of negative 35, which are negative 1 and 35, negative 35 and 1, negative 5 and 7, and negative 7 and 5. The thing we need to do next is try different combinations of these factors of both 18 and negative 35 around the outside of the box to see which combination works. And if we are systematic in this process, we can go through all the possible combinations and find the proper factors pretty quickly. The first product I decide to work with is the negative 35. Why is that? It's because if you dismiss the negative and positive differences, there are fewer factors to 35, so it will be more efficient to work with the factors of 35 first, then try out the factors of 18 to put the right combination together. And I'll first work with the 5 and 7 combination. So we'll start out by placing the 7 on the top of the box and the 5 on the left side of the box. Note that neither 5 nor 7 has a negative sign. It's because at this stage we're trying to stay more flexible in order to sort through the different combinations more quickly. Next we'll try the factors of 18. Usually I've found it a good idea to start with the factors whose numbers are closest together. In this case it would be the 3 and 6 combination. We'll place the 3x on top of the box and the 6x on the side of the box. 3x and 6x are factors of 18x squared. Next, we multiply the terms together to fill out the remainder of the box. 7 times 6x is 42x and goes in the upper right cell of the box. And then we fill in the lower left cell of the box, and that's 5 times 3x, which equals 15x. Next, since we have different signs between the 5 and the 7, we need to combine the like terms by finding the difference of 42x and 15x, which is 27x. And since 27x does not match up with the 9x in the original quadratic trinomial, at least that x term, we know that this particular combination will not work. Therefore, we now know that we need to try another combination. As a next possibility, and this is systematic, we'll switch positions of the 3x and 6x terms. And here are the 6x and 3x terms switched. The 6x is now on the top and the 3x on the side. With this combination, the upper right cell becomes 3x times 7, which equals 21x. And then the lower left cell, we have 5 times 6x, which equals 30x. And combining like terms to find the difference, 30x minus 21x equals 9x. In this case, we know that the combination of the two terms, 9x, equals the original x term of our original quadratic trinomial. And this shows that we have found the correct number combination. Since we now have the correct combination, we need to determine next which numbers of the 7 and 5 will get the plus and minus signs. Since the x term is plus 9x, we need the 30x to be positive and the 21x to be negative, because that's the only way it will work out to get positive 9x. So we do that by making the 5 positive and the 7 negative. And that gives us negative 21x in the upper right cell. The 30x in the lower left cell still remains positive. And as a check, combining like terms, we get 30x minus 21x, which equals 9x, as in positive 9x. So now we know that 18x squared plus 9x minus 35 is equivalent to quantity 3x plus 5 times quantity 6x minus 7. If we hadn't found the factors by now, we would go on to try 2 and 9 as the factors of 18, then 1 and 18, and even go back to the 1 and 35 and for 35 to see if we could get anything to work. Sometimes it won't work out, so the trinomial is factorable. Some quadratic trinomials are not factorable. Next, we go on about finding the solutions using the two factors we've obtained. This equation, quantity 3x plus 5 times quantity 6x minus 7 equals 0, is a true statement if either of these factors, quantity 3x plus 5 or quantity 6x minus 7, is equal to 0. So to find the solutions to the equation, we break out the two factors into separate equations equaling 0. We have 3x plus 5 equals 0 and 6x minus 7 equals 0. Solving the left equation first, we subtract 5 from both sides of the equation. 5 minus 5 cancel to equal 0. Bring down what's left, we have 3x equals negative 5. In dividing both sides by 3, we have one solution as x equals negative 5/3, which as a mixed number is negative 1 2/3. And for the other solution, we add 7 to both sides of the equation. Negative 7 plus 7 cancel to equal 0. We bring down what's left, and that's 6x equals 7. And solving for x by dividing both sides of the equation by 6, we have x equals 7/6, which as a mixed number is 1 and 1/6. To be certain, I checked on the graphing calculator. We can see that the 0 on the left is negative 1.67, which is negative 5/3, rounded to the nearest hundredth place. And on the right side, we can see the positive 0 a little greater than 1. I checked that one too, and it's correct as well. So we write down our two solutions in set notation above and box them in as our correct answers. And in brackets as shown, that means that each number within the brackets separated by the comma is a distinct correct answer. Although this video lesson here took quite some time, in reality when I did it, it was a lot faster because of my experience level. In this lesson, I tried to go through my thought process as I would go about solving such a problem. I hope this lesson will help out Viva La Maria and many others. Perhaps Viva La Maria will want to be one of my subscribers. This has been Solve Quadratic Trinomials by Factoring Using the Box Method, a harder problem. Thanks for viewing.